Yeah, so here you choose maybe where you trust the source. Maybe think they are better. I remember I used to choose from ETH. ETH is where are they gone now? ETH is like the Harvard of Europe, you know. Anyway, but you need to look at the location of the package because it is going to download. So wherever it is, the download speed and the location is important. So usually the best advice is to choose the first one, zero cloud. That will optimize your location and choose the one that is closest. Okay, so we'll just forget about all these other countries and choose the first one, zero cloud. And that should start the installation of the software for you. So you do of the package, you do hello. You do okay, and then it will install. So if you have this, then your package is installed. You can run the next one, which is the STS. Okay, so that's done. So you realize that you were asked to create a library. All the packages are in that library. As long as they are there, you don't have to install them again. So if I copy my library, for example, for you, and you put it on your installation folder, you have all my packages. You don't have to install them. There's also another way. I can download the zip files of the packages, and if I give them to you and you don't have internet, they will install. However, when you're installing a package, it also installs other packages that depend on them. We call them dependencies. So once you're online and it's downloading Zoo, it will bring all other packages that the Zoo needs to work with. But if you just install the zip file, you have the problem of not getting all the dependencies. So that's why it's always good to have internet to install packages. Install them from the CRAN directly. If you look at the next line, realize I've put a number of packages together to install them at once. Okay. So if you know the packages that you want to use, instead of doing them one by one, you can put all of them together and look at how it is done. You create a vector of all the packages and they can install once you run the line. But you should know that if your package, your internet is good enough to download all of them, because some are heavy. When you install the package, you do it once. So tomorrow or whenever you need to use performance analytics, use STS or use Zoo, you won't have to run these lines again. Unless you have uninstalled the whole of the R from your PC and you install again. Once it's installed, it's sitting on your PC until the day you remove it. Whether you remove your whole library or you remove the R from the software, from the PC. But whenever you start R, you have to call those packages into use. Okay. And you do that by using the library function or require function. So whichever is easier for you to type, you use. I usually use the require function because it's easier for me to type require than to type library. In some codes, you will see that they have quotations here. It doesn't matter. You don't need it. So if you run this line here, it will now bring the package into use in your current session. So that if you are going to use a function that is inside that package, it will work. STS, which depends on the Zoo, they help you to create extensible objects. By extensible, if you are working with time series data, you should be able to link your date column with the data so that when you plot, you can see your dates in the horizontal axis. Then the performance analytics helps you to do a lot of things. So much, calculate value at risk and all of those things. But at this point, what we need it for is to calculate returns. We know the difference between returns and prices, right? So normally when you are working, you are modeling, you work with returns instead of the prices, because returns tell us about the reward from an investment. The whole difference between selling price and cost price, that's the return. In those days, we call it profit. They are just slightly different how we calculate them. One statistical property for us to use returns is that it is stationary. So we know what stationarity and non-stationarity is. Or we need a performance analytics for. And that's so much, but that's what we need for in this context. So that you don't have to, you can do those calculations in Excel before you bring them here. Usually that's what I do. If I don't need it to pre-process my data, I'll just do the returns in Excel before I load the data. But here, I want to show you because you need it at certain points in time. So this is how you install packages. I know what these packages do. That's why I installed them. And you know with time which package you need and which package you don't need. So we need to bring in data. We need to bring in data that we are going to work with. So the first thing we should do is to set our working directory, okay, great. Now, what I want you to look at is the date column. Look at it very well. Do you see how the date is arranged, the format? That is extremely important. If you are going to do any analysis in R where your date is important for you, for example, in the bivariate wavelet analysis, your date should be arranged like this, almost by compulsion. There's no way around it. I mean, there's another way, but that is a whole line of codes, like 5 or 10 lines of codes, which you don't have to go through. So make sure your date column is arranged in this form. Okay. So suppose you have this data, year, month, day, that column. This column here, this column. It should be arranged in this format, year, month, day. Are we good? Have it in Excel like that. If not, you need about 10 lines of code to change it in R to this format, which there's no point to do that. So the best thing is to go into Excel where your original data is and format the date column to that. And I believe that one is something that maybe you do every day. So you format the column, and if you choose this, it should give you that. So what you want to do is you want to attach the variables in the data, in the table, so that you don't always have to use the $sign to bind them, right? Or you don't have to use the matrix notation to access the object. So now we should change this to GHS. Want to attach our GHS and EGS. So if we do that, we run these two lines. Please do run them. Let's see. What did you get?
Some plenty numbers.
Plenty numbers. So have you run the dates, Gs and EGT?
Dates. GH.
How did you get the plenty numbers?
Let me run that one. So I ran the attached GHS line.
Yeah. So now when you run the date, GH and EGT, they work. Earlier, I realized that they were not working without the dollar sign. But now they work because you have attached them. And that is very important. It helps you to work faster. And when you have a lot of variables to deal with, you don't have to be worried about using the dollar sign. You can always call the variables, let me say the columns in your object or in your table.
My attached GHS gave me data.frame as the output.
Attach?
No, okay, so that was attach. Okay, so it attach GHS for easy access to elements. It didn't.
Okay.
It didn't
give you
me
anything.
No.
It's okay. So if you run the attach, then you can go back and move on and run date, GH and EGT. They should work. If those work, it means your attach was successful. If they don't, then something is wrong.
I should run the date.
Okay, yes, run them and let's see.
So, and the attached there is date, so I should just complete it with the GHS.
Complete it? What do you mean? Just run the lines. The 3 lines that you see, they run them one after the other.
Okay.
If you have an error, let me know.
Okay, let me look on your screen. Date, GH, EGT. These are the 3 lines you are talking about. And the attached, yes.
Yes. You should also run if you look, I have also written attach EGS. Should do that one as well.
Okay.
Okay.
So the dates gave me a lot of numbers.
So now it's working now. So when you put date, they know that date is coming either from EGS or GHS. If you do GH, it will pull the data from GHS. But previously, we realized that they were not working until we added the dollar signs. Do you remember?
Yeah.
Hey, you are not following.
Yeah.
Okay, so that's fine. If you want to remove, if you want to forget about, if you want to detach, you can run this line. So, but we are not interested in detaching, so leave it. See the detached line?
Mm.
If you want to go back to previous, when you just type GH and EGT, you will not get the output. Then you can detach this with this line. Okay. So that's what I want to explain to you, and then we are going to need it. Okay. So now let's move on. Let's move on from here. From here, let's move on. So what you realize here is that we just load the data and attach so that we move fast. All things being equal, you should have all these data files there. There shouldn't be a problem. So run them. Shouldn't have errors. Okay. Okay. Are you where I am? You shouldn't have any errors at all.
No, where are we running from? It went fast.
Here. From here all the way down to here.
Okay. Okay.
And those lines. Are we there?
Yes.
Both of you. So we can move on.
From my end, yes.
1 sec. Okay.
Evidence, do you have issues?
No.
No issues. Okay. So skip these lines. We will come back to them. Skip them. Okay. So anyway. Okay, so run this line. This line here.
The plot.
Yes, the plot. So we plotted one of them, NIG. So you can plot another one. Let's say we have SC, right? Plot another one. Yes. Okay. Then you can plot the third one. So just plot all of them and see how they look like. I want to show you something. So we have EGT. Okay, that one also. The last one is GHA, right? The x-axis should be a date column. I mean, it should show the dates, but it's not showing. Because as it stands now, the data is not linked with the date. They are in different columns. They don't know each other. So what we want to do is to put them together so that when we plot, the dates will also come. And that's what you want. If you are presenting your work and you plot this, and if you want to explain your data, your plot, you cannot say between 1,000 and 1,500 there was high volatility or low volatility. You need to be able to tell us when in calendar time that happened. And it makes sense if you have your data presented that way. That's how you can analyze your data better. If you don't know your dates. But what does 3,000 mean? It means nothing. It's supposed to be a calendar time for us to make inferences. So we know that then during this period, the prices were high or low, they were falling or they were rising. And we can go back in reality and see what was the circumstance in the market at that particular time. So let's do that. We want to be able to get the date to show. And that's the purpose of the STS package you remember we loaded earlier. And it's to create extensible options, extensible object. Okay, so this is what we want to do. Follow me very carefully, because if you miss this one, you will struggle. So are you following? Are you following?
Yes.
Okay, so look at this. I'm starting with NAG. So I just wanted to be sure of what the names in the data are. So we have NIG and dates, okay? So what I want to do is that I want to create a date object and bind it with the variable, the NIG. So to be sure, I want to say that this date here, this date, I want to pick it from the NIG data. So NIG dollar date. Okay, does that make sense? Yes. So this date here, I want to create a date that is coming from the NIG data. So you run that line. That should be fine. Now this date, R doesn't know that it is date. R doesn't know. So for you to tell R that this column that you have created, it should be date, you should run this line. So as dot date, remember this is capital, it's not small. This is a function. So this date here, want R to look at it as a date or make it a date. So as date, what? Date. If this is just a name, you could have put any name there, but it makes sense that we use date because we are talking about calendar date. If I run this line, I have created my date column to be known as date in R. So that is done. Are we good? Okay. Now, the price data itself, I want to also put that one aside. I want to take that one aside. So I'll say the price is nig.p, and I'll pick that one. I'll pick that one. Are you good? So the next thing is that I'm creating a new object called ng. And for that ng, I want to bind the date and the price together. They will no longer be two separate columns. They are just one file. And I use the XTS function. So XTS, this price here that I have, and the date that I've created. If I run that one, it is done. Now, if I look at my head, it will be one column. Can you see? It looks like 2 columns, but it is 1 because you realize that there are no headings. Can you see that there are no headings? Yeah, so it has become 1 now. If I run the dimension, you see, it's 1 column. Are you following?
Yeah.
Yes. Then if I plot, you realize that it's no longer giving me that nonsense of those numbers. It is now picking the exact dates from the data, and I can make sense of this. Providence, do you realize that it has arranged the dates on its own?
Yes.
So if you need to explain or talk about this plot, you can, because you can make reference to 2008 January, and the prices were very high, and they started dropping just afterwards. Yeah, so this is better to talk about. That's the first thing. So when you have any data, you should convert them into data frame. If you converted them to STS so that you can plot them. That's just one way of doing that. So this is all these codes here, that's what they are doing. So I put, this is just repetition. So this is for Nigeria, this is for SA, this is for Egypt, and this is for, so we can change this one to be for Ghana. Okay, so this is what I'm going, so I'll let you run these 3, and then when you get to Ghana, I want you to make the modification and see if you get it. Okay, so let's run the lines all the way. Okay, so this is, let me show you something in Excel. If I take this data, for example, I hope you can see this screen.
Yeah.
Okay, so we know returns. Simple returns, log returns, all those ones. Usually you can work with log returns, but you have to be sure if you are working with typical macroeconomic variables, you may not need returns, you may just need to log them. But generally, for returns, it is, I have my board here, let me see. Let me see if I can. This whiteboard thing, what does it do? Okay, let me just annotate. So you see returns, let's say our prices, RT, like this, equal to, so you have your prices. The simple returns is like this, PT minus PT minus 1 divided by PT minus 1. I hope you remember this thing.
Yes.
Yeah.
So this is the current price, this is the previous price, and this is the previous price. So this is the simple returns, which you can calculate in Excel. So, or you can use the log returns. Let's say log returns is RT. So it is len, so PT minus len PT minus 1. We are good on that. So this is what you want to do. You go to, in R, clean this thing from the screen. This is what you want to do. So you either do it in Excel, so that when you come here, your data is prices or returns. It's up to you. But you may need both your prices and your returns in Excel in the R console. But if you are using the performance analytics package, so you can calculate the returns this way. Here. So you see, it says, I give a name GHR, gh.r, just to distinguish it from returns, from prices. And the function is calculate returns. You see, it is C is capital, R is capital. So if I'm doing GH, then I can change this one to is GHA. Actually, I didn't do my GHA, so let me do mine quickly. So GHA, GH, GHA, H, and the GH.P, and the GH.P. Let's see. GHA. Okay, so GHA. Okay, so we are on the same level now. So what I want to do is that I want to find the returns of gh.p, gh.p. Okay, so here I'm doing the log return, but if I change this to simple, it means I'm doing the simple returns. Are we good?
Yeah.
Yeah, so it's up to you, but usually log returns are better for a number of reasons. So log. Now, this one means that I'm going to I'm removing the first column. If you look here, for returns, it means I'll start from here. Because I'm going to short one variable, one observation. So this column that I'm missing, this observation that I'm missing here, is what I'm capturing with this one. Are we good?
Yes.
Yes. So if I run this line, I'll have returns now. And if you realize, look at the dimension. It's now 2938 instead of 2939. So we are missing that one at the top or at the bottom, depending on which format you go, which direction you go. Okay. Are we good? Now, look at something. Something I should have let you know. So gh.p is a class of gh.p is STS or zoo. So the performance analytics package, which calculates returns for you, accepts only STS objects. STS object. That's why I checked it for you. Do you remember when we loaded GHS at the top? We didn't remove it, right? GHS at the top. And that is data frame. If I put it here, it will not work. See, it says cannot converted into a time series. Method is called XTS. So we need XTS object instead of a data frame object. So the whole process of going through the XTS was to get the prices, no, the date in the plot. Also, if you want to use the performance analytics to calculate returns, the object that we should use should be an XTS or a zoo object. That is Y. Okay, so that is it. Now, okay, so let's do that. Let's run it and see. You can change it to any other variable that you want. So calculate the returns for Ghana, South Africa, Egypt, and Nigeria. Do not run the plots here. We'll come back to it. I want you to get the returns done. So I'll do my SA returns. I'll do my Ghana, Egypt, and all of that. And give me a NG. What did I do for NG and NG? So any issues or no issues? So this is what you want to do. What if you want to compare, say, the price and the return in the same plot? Yeah. So this is what I'm doing with the MPF. So here, per MF row. So we want to create a data. A graph sheet of one row but two columns, and want to put both the prices of Ghana and the returns of Ghana to compare. Okay. By the way, plot the Ghana alone and see how it looks like. You see the difference between the two variables, the price and the return. You saw price earlier, this is the return. But maybe you want to put them together side by side. So I can run this, open the graph sheet, and then I'll put them there. Okay. Or maybe I want to put them on top of each other. Maybe I want to put them on top of each other. So choose which one you want. How far?
Doc, so on the returns on the Nigeria one, it said that the data cannot be converted into a time series.
Okay, so how did you, if you go to Nigeria, what was the name that you gave to it? The STS object, the last one, for the prices. When you converted to prices, what name did you give it? Let me see your screen. I'll show you.
Yeah. Yeah.
My internet. Okay. So go up to let's go to returns Nigeria. Okay, energy, right? Wait. Providence. Okay, let's go to energy. Nigeria. Up. No.
Still up.
Yes, end it there. So
okay.
We are going to high. Go to where we converted to STS there. Yeah, it's okay. Your final STS object for Nigeria is NG. NG, right?
NG.
Yes, that's it. Okay,
yeah.
Now let's go to calculate the returns. Let's go down to where we calculate returns. And which one are you calculating for Nigeria? Is it that one?
Yeah.
Yes, it will
so
not
I
work.
change it to NG.
No, not there. No, not that one. Here. Can you see my mouse? See the variable that you want to stay there. Just stay there.
Okay.
It is nig.r is what you are defining to be your returns. So that one has no problem. But the object that you want to convert to returns is the ng, which you just saw there, because that's the one you decided the name to be. So nig, nig is not what you need, it's ng there, yes. And this one should work.
Okay. So it applies same for all of these ones as well.
No.
They should read it.
No.
It doesn't apply to them.
It doesn't. So you have to be careful.
Okay.
You are at this stage, this one shouldn't be a problem. See, you want to convert this energy from prices to returns. And that price, that return, you are named as nig.r. So once you do this, going forward, there's no longer ng. So here, you want to see the head of nig, that's fine. But if you want to see the head of ng, that's also fine. But it doesn't, they have nothing in common. So run this line and let's see, you shouldn't have any errors. Where you are running. Yes. So you can run the remaining lines. Go on. Go on, plot it and let's see. Plot.
This one.
Yes. Plot and let's see. That line, you don't need it. But plot this one.
I don't need this line.
You don't need it for anything. If you want it, you can do it. But at this, the GH head the G.R there, you don't need it for anything. What I want you to do is to plot this returns for Nigeria for me. You don't need a space. Go back. When you have a bracket to deal with, don't put space in between.
Okay.
Can you go back? Go back to the plot, clean and go back. The reason I wanted you to go back that whenever you have a bracket quotation, you need to type and close the bracket before going back into to type whatever is inside. But that's fine. You have to practice that one. Otherwise, you run into problems.
Okay.
But I saw something up there and I need to address it. Go to Ghana, where you calculated returns for Ghana.
Yeah.
Yes, you realize that for the returns that you have named as gh.r, you will put Nigeria data there. So you have to change it to, how did you name it? Is that how you named it? Is that how you named your prices when you converted it to STS?
GHA, I guess.
So confirm. Yes, that's what you did. So that's fine. So earlier, so run this line. Before that gh.r that you had was for Nigeria. It wasn't for Ghana.
Yeah.
So good. Then I just wanted you to plot the two side by side. So I want you to plot the prices and the returns for each of them. So if you are plotting price and return, it should be for Ghana, both for Ghana, not for Nigeria and Ghana.
Plot.
No. It's where you are after per MF row down. So what is there now is for the plot of prices for Nigeria and returns for Ghana. We don't, so you can, now if you do this, then you can compare Ghana and Ghana prices and Ghana returns. So do so run from the top, the previous line.
Okay.
Then you can plot them together. Run it quick. Yeah. So this is what I wanted us to see. So you can do this for all the others. When you finish, you can do this for all the others. And you can change it to whether they should lie on top of each other or side by side.